Alright, here we go. So today we'll talk about a few things that can be different with the vertical motion word problems. Just to review, the vertical motion model says what? What is our equation? Sal?
H equals negative 16 t squared plus 3t plus s. Vt.
Right, or v. The initial...
Yeah, initial vertical velocity times...
Right, so this is the height. This is the time. This is the initial vertical
initial height.
And this is the starting height. Okay. The first thing I want to talk about is this negative 16. So negative 16 is the number to use when your unit is feet. I'm going to call that A because that's what we usually call the number out in front of the squared term in a quadratic. So A is negative 16 when our unit is feet. You may see problems, and you'll see one on the homework, where your unit is meters.
Meters.
So when the unit is meters, use negative 4.9.
What?
For A. Seems like a little bit of a weird number. If we get a chance, I'll tell you later where these come from, because it is a little. It's kind of interesting to me as a science teacher, but you'll definitely learn more about that in physics and this. So if I had meters, if all my units were given in meters, I would just change this equation by using negative 4.9. Does that make sense?
Yeah.
A pretty simple change. You then have a decimal, so things can get a little bit more complicated, which is why we started with the feet. But use a calculator in that case. So let's just quickly, we're not going to solve this example, but let's just do an example of a problem like this. If I said, Nathan throws a baseball from the outfield.
Are you implying that it's the outfield?
To first base. With an initial vertical velocity of let's say 12 meters per second. Write an equation to and what we're going to say is assume Nathan So all we're going to do is write an equation to model this. Our equation would start with h equals. And then since my units here are all meters, I'm going to use what number? Negative 4.9 t squared. What's my initial vertical velocity? 12, and so I just use the 12 there. T, and then what's my starting height? 1. So that would be the equation that would model this problem. Then we could solve for the vertex, or we could find the zeros. Or we could do-
meters.
Right, and it would just be the same process that we've been doing, with the difference that we have negative 4.9 there instead of negative 16. All right. Let's. Can I erase this top part? No, not yet. Let's just look really quickly at one other thing. What if I asked you? Let's say Nathan's throwing from the outfield, and we've got a base runner, and the base runner is trying to get to second base, and it takes him 5 seconds to get to second base. So if the base runner takes 5 seconds to get between the bases, I want to know, where is Nathan's ball that he threw after 5 seconds? So my question is, after 5 seconds, how
5
high
seconds after 5 seconds.
is the baseball? Okay. So I've just given you one additional piece of information. We're not solving for the vertex. We're not solving for the zeros. What are we going to do? How are we going to use this 5 seconds?
It's
Plug it in. So we are going to plug it in. What is 5 seconds? Is it
time.
our h or is it our t? It's a time, so it's going to be our t. So then we're going to solve h equals negative 4.9 times 5 squared plus 12 times 5 plus 1. This is going to be h equals 25 times negative
122.
negative 122.5, thank you, plus 60 plus 1.
Negative 12.25.
Yeah, so our answer is going to be a negative height. Negative, what is that? 21.5, right? Negative 21.5 is our height. So that means that the ball has already completed its arc. Right, if we were to graph that,
How can that be negative?
Well, how could you graph it? It'll be like, wow.
it makes, so this doesn't make any sense in terms of the word problem. It does make sense on the ground. So the ball is already somewhere down here, right? Which means, if my question were, did he beat the base runner?
Yes.
Then yes, he did beat the base runner, assuming
You said he's
assuming that he threw it far enough.
throwing to first base.
That's right.
There's a force out at first
that
base.
would defeat the purpose.
There's a force out at first base, exactly. So, but he still has to beat the base runner to get the force out.
Yeah, but
No, but
So if I had asked you a more technical question, right, the answer would have been yes, he beat the base runner, assuming he threw it far enough.
Well,
And the
it would
piece
be
that we
negative
haven't talked about yet is horizontal motion. right? And you'll probably learn that in high school physics.
So it would be
To analyze
negative
the
21
horizontal.
meters under the ground or feet under the ground?
And right, and so then our answer is negative 21.5 meters. So this ball has gone way down. Probably my words are not very, my initial word problem is not very accurate for how someone would.
Wait, why did he get negative 21?
Why? How did we get that?
Because
We had negative 122.5 plus 60 plus 1.
Wait, and that equals negative 21.5.
I think so.
I don't think so. No, it's like 4.
Yeah, it would have to be like plus 100 plus 1 equal 1 or equal.
Oh, I'm sorry, negative 61.5. Yeah, I did that wrong.
Yeah, it's like what's
Negative 61, so it's even farther down. Right now we're way down here.
You beat him good.
Yeah.
Well, the vertical velocity is quite fast. It's like if you convert meters into feet, that's like 40,
36.
36
Yeah.
meters.
It's like.
Okay. So if you're given a time, you can plug the time in to find the height. The last thing that I want to talk about is the initial vertical velocity. And on the homework tonight, I additionally put some challenge problems that have other kind of weird things that you haven't seen yet. You can do those if you have time. If you don't have time, feel free to skip the challenges. But I'm going to tell you everything you need to do the problems on the homework, other than the challenges. So if we have an initial vertical velocity, right, which we called our v. So in the equation we have h equals, hopefully you already have this in your notes, but negative 16 t squared plus vt. So talking about that v.
That particular V.
What if v is negative? And this can happen. So if I am standing up, let's say Juliana is standing up here,
And she like drops it.
right? Yeah, I did my too far away. She's standing right on the edge of the cliff.
And she's oh,
She's on the top of the Empire State Building, and she has in her hand a penny.
They don't know like
At that moment,
Unfortunate date.
that's a large penny, right? At the moment that, she releases it, she might just drop this object, which would mean it would have no initial vertical velocity. But what if
She
she
goes
threw it down?
and have negative.
It would have negative vertical velocity. So if you get a problem that says something like Juliana throws a penny
Dog.
downwards from the top of the Empire State Building. With a velocity of
Why is that J though?
building. I abbreviated building, I'm sorry. With a velocity of, let's say, 13 meters per second. And then we're going to say model
After the nation
Yes.
for a baseball.
equation. I don't know the height of the Empire State Building, so let's just say the height of the Empire State Building is 1
100 meters.
million meters,
Oh my goodness.
which
It's totally a million.
it's not. Okay, let's just say that it is though. then let's model this. So h equals
Yeah, throws a baseball.
H equals 1 negative 6. Wait, is it meters?
okay.
No.
So we're in meters. So we're going to use negative 16,
What million?
negative 4.9
9 minus
t squared. And now I said she's throwing it downwards. So my initial vertical velocity is negative 13. And then my height is
1 million.
1 million.
Yay.
Can we solve this?
Well, I didn't give you anything to solve for, right? You could find.
We have 2 velocities.
We
We have 2 variables, right?
How long will it take?
No,
to
we
get
only have
to-
t,
Oh,
right?
yeah.
Well, I mean, we have h and t, right? So if you were to solve this, you would graph it. That would be the only way to solve this, per se. If I had asked you something specific, like after how long does it hit the ground, then you could solve for that. All right. Those are the 3 things that I wanted to talk about, and we're out of time.